So, a little bit about the rest of the course. This week's exercises, I would like to have a 1 hour time slot where we can discuss about your progress during the project work. So if you have some progress in the project work, maybe you can tell about that and tell if you are stuck in some places or if you have questions or problems starting it or anything like that. So 1 hour during the exercises this week, we are going to focus on that. And I think that for the next week, because next week there will not be any lectures, that would be good time for you to develop the project even further, because you don't have this to worry about exercises or coming to lectures. So I would expect that to be a good time to have progress on the projects. And after that, I'm going to be in Kuopio this one week. But while you are working on the projects, don't hesitate to email or ask me questions. I will not be in the office next week, but actually I will be in Kuopio. So if somebody in Kuopio would like to meet with some project problems, then I could pass by the university someday.
Yeah, you can celebrate the Labor Day with yourself, with you.
Sorry?
We can celebrate the Labor Day.
Yes, that's why
I guess.
That's why I'm coming.
Good.
Okay, yeah, so anyway, you can ask me questions about the projects and I can still answer next week. And a little bit more info about the projects. So the projects I would like, I would like at the end to have the source code of the projects, because I needed to first evaluate it, and also if you will pass the course based on the project, the source code will be like an exam. So if somebody asks how did that student pass the project, I need to demonstrate somehow that this is what the student did. And secondly, by default, I would like to put the project available to the other students, so maybe on the web page. If you think that your project is so good that you want to make it into a company, into a business or something really cool, you can just tell me and I will not put it there. But by default, the project will go also on the course webpage, and also the source code if possible. So the idea is just that if somebody is really interested to learn about it, they can try and reproduce your project. So it's kind of like a learning environment. But again, the source and the project may not be there if you specifically tell me I don't want it to be there. So it's no problem, but the hope is that we have some set of applications that everybody can play with and learn from them. Okay, so I think that is almost everything. Yeah, and my video editor that I use to make the videos, the license expired. So now the videos are going to be a bit more boring. They will only have this me teaching stuff on the board, at least until I get another license somehow. So I will have to ask admin at university for that. I was using this 30-day trial period, so it ended. Right, so let's go to today's topic. So today's topic is going to be analyzing some other software, other applications. These two different applications. One is called Strava and the other one is called Waze. And I will try to explain what they are doing by focusing on their web page. I can't focus on the app, on the mobile app, because for Mopsy I had the APK there that I could install on the emulator and demonstrate, but these ones are not easy to install on such emulator and pretend that you are driving or running around the city, so it would not be very useful if I just put it on my mobile phone and show you this screen there. So we will look at the web page and maybe some screenshots or whatever, and I will explain a little bit about how the mobile works. But yeah, so we can begin with this Strava application. And what Strava is it's a sports tracker. So it's a sports tracker. It became very popular for cyclists at the beginning, but now it's more general. You can add anything there. You can add running, you can even add swimming, or if you go to the gym, you can add that. It could be just manually entering how many hours you're working out, but so not necessarily always tracking what you're doing, but keeping track of your sports routines. And first of all, we see here this nice screen, very simple, very empty. A small demonstration here that it works on mobile phones and even on some of these smartwatches. It's available also for that. And 3 sign-in options. So these are usually very useful to have because users don't want to remember passwords for everything. There are password managers, you can use those, but nowadays having apps on mobile, having apps on the watch, even the password managers don't work everywhere, so it's tedious. And having a sign-in with Facebook or with Google is usually a very good thing to have in your app. You don't have to worry about it, and you also don't have to worry about encryption. So encrypting information such as your password is very important because you don't want some hacker to steal your database contents. If it happens when you're using these systems, then you can blame it on somebody else. So it's always a good thing to leave the others to have the high-level login features there that are usually superior to what you can make because they have a very large team focused on only security issues. Yeah, so for this I'm going to demonstrate signing up with Google. Yeah, and my activity in Strava is not very big. It's actually quite limited because I use Mopsy. But I have some things here that we can talk about, and we can explain how it is different from Mopsy, and also what makes it very popular, like a really popular app. There is a dashboard here, and there's a small bug there. So nothing, it's not necessarily perfect, even though it's a very popular app. I don't have any routes, so these are, unlike in Mopsy, they use the word route to mean a specific place that you are going to do an activity, and they use a different word called track or trace or trajectory that means your instance on that path. So you can go 10 times on the same route and have 10 different tracks on the same route, or 100 different tracks, or other people can go on your route, or so on. So this activity, these activities here are essentially the same as the routes are recorded in Mopsy, and you can see they have some predefined names here, simple ones like lunch ride or running, cycling, skiing. These are manually entered by the person when you are doing the activity. And after you are opening this activity, you will be able to see the track on the map and some statistics about the track here. For example, this is the speed, I think. Yes, and at the bottom, something very interesting that is, I think, unique to Strava. I might be wrong, but I think Strava is the only one that has this feature. It has a feature called segments, which means that you can define a specific stretch of road on which you will compete with everybody else and be ranked on top of each other. For example, if we open this segment, it is here on this part of this trajectory, and it says here that I am ranked number 47 out of, I don't even know how many they are. I can press here to view the full leaderboard. But anyway, this is a very nice feature. It says the speed that you have here on the segment. And the very, very funny thing I noticed yesterday is that I know this guy and I cycled with him one time. But we cycled, we never cycled that specific route. But we have exactly the same speed. So it's funny that you tend to meet people that are similar to you, but this is really bizarre how similar it is, and his name was there, so I have to call him, tell him, did you know that we have the same cycling speed? So this is a very nice feature, and you can see here that Strava has basically a social network built into it. So it has the users public by default, and you can interact with them and see these kind of interesting statistics throughout the application. And it's also very much on a competitive basis. So here I know that I have more to work if I want to be better on this segment. So this competition it increases your motivation, because I could look at the statistics and I could think I could do better than that. So then I go there again, and specifically on this one segment I will try my best, and only to see if I can rank higher on this list. So it motivates you more than just going cycling alone without any aim. It gives you a goal in mind. And I think this is one of the things that makes it a very popular app. You have goals, but not just one. You have multiple goals. So if you check here, this specific route has multiple of these segments existing, and I rank differently on different ones. So it gives you many top lists, if you may. So many chances to become better and to score higher on these lists. Of course, I would say it's quite unrealistic to try to be on the first, but it's still some feel-good effect if you are going to rank just higher than yourself. So first of all, you're competing with somebody, but then you might also want to be better than one friend or somebody who is continuously on a lower rank than you. Yes?
How do they are setting these segments?
Yes, okay. So there is a feature here. If I scroll down the page, create a new segment. So the way this works is that you take the route that you have recorded, which is here, and you simply move these slider ends here on the top, to select part of the route that you consider a segment. So in this case, it is this part here. Now, this is a bit of a problem. It's a manual creation, and it also might overlap with some other segments. So I consider it a problem in Strava because some people might consider this as a segment, some other person might consider this as a segment, and some other person might consider all of it as a segment. So then you get these segments that are overlapping, many segments that are overlapping, and it becomes too confusing. Too many segments start to appear in the same track. And it also means that you have to do it manually, so to create these different segments. And another reason why I consider it a bit bad is the GPS error. So if this trajectory here has some GPS error, then you will create a segment with GPS error that all the other people will get scored on. So a little bit of a problem also from this stage. But nonetheless, I think it is still one of the best features I have seen in any sports tracker, because some of the segments have a very meaningful property associated to them. And maybe you know that you are going somewhere on a very steep hill, so it's very likely that many people will relate to this hill and will understand that, okay, I know exactly what this segment is, I know exactly where I need to go faster next time if I want to compete. So I'm not exactly sure how they maintain all the segments, but if you try to view them on the map, you will see that a lot of them overlap. So a bit, they have pros and cons, if you will. But yeah.
I guess if you want to complete the time, you have to come to opposite way from the top to the down.
Yes. So that's another thing.
Yeah. What about how they can compare these segments if they are different? Or
the direction.
You feel just to join something.
Yeah. Okay, I understand. So you mean if the direction is different?
Yeah, and the whole way can be.
Yeah, the whole way can be different. In Strava, they take into account this direction. So I'm going to open Mopsy a little bit because I have some tools there that are very related to this. So I don't know for sure how they are doing it, but I'm pretty sure that they use some route or trajectory similarity function for computing the similarity between the segment that you create and any other route in the database. So they want to see if the segment is part of any other route in the database. And here, this demo application here, it has two routes, this black route and this blue route, and they are very similar to each other. They are very close to each other, first of all, and they are both going down in this down direction. And this measure here that I select on this top, this LCSS, it gives 100% similarity for these two routes. Okay? Some other measure here, this is something that we invented, gives also 100%. This EDR is a bit similar to this LCSS, but because the black route has more points than the blue route, it has some points that become unmatched. So now this percentage here goes a little down. And then there are also some other measures here that are useful, but not in this context. So the sports trackers usually stay away from these ones, I think. But most likely they use something from here. And I will tell you why in just a second. I don't know if I have here a demo with that, but yeah, so okay, there. Okay, I don't have a demonstration for that, but maybe I can show some other way. So let's keep these two routes. Yeah, and check out how the points of these two routes look like. So very simple, very simple locations there. I want to see what happens if I sort these locations in the other direction. So I pretend that one route is in reverse. Okay? Because that was your question before. What happens if you go the opposite direction? So I don't know any other way to do this right now than to open Excel. Go back here. I'm going to copy the blue route. I'm going to paste it here. I go to the data and I separate what I have here into columns. And I say that the comma is this thing that will make them into two columns. So now we have two columns here, B and C, but we need an ordering here. So I'm going to start with 1, 2, all the way until 14. And now what I'm going to do is I'm going to sort the A column in reverse order. So, and expanding the selection is going to sort everything in the opposite order. I copy the new data, maybe in something else than this, please. Not very good, but and I don't like it because this format here needs a comma between the two things. More hacking, I take this column from here, I paste it here, and here I enter a comma that I replicate everywhere. So I'm just thinking, how can I do this now? This is a bit better, but I don't know how these spaces will be interpreted in that thing. Let's open also Notepad and see what it's saying. Okay, so something is better. Can it replace stuff? Yes? Any comments? So I can't replace this space because Notepad doesn't know how to do it. But I copy it again to WordPad without the other fancy things, and I do that. Again, please learn how to use these things better and teach me, and never do something like this before in front of people because you look like you don't know how to use computers. Why is it shorter? Oh, okay, missing some points. I can promise I know how to do this much better on my own computer. Don't laugh too much at me. Okay, recalculate. So now this blue route here is going to the top. In the arrow is upwards here, and the black route is going to the bottom. And you see how this 100% similarity dropped to 40. It was 100% before. So this particular measure and this particular measure, they dropped very much when the routes were in reverse order. So the similarity function that they use has this property. I don't know if they use this one or this one, but I would guess that's something like that. So this here stands for longest common subsequence. And this one here stands for edit distance. This should be very familiar to you. On real sequence. So both of them are from the same family, from this family of edit distance. If you have taken the DAA course, this edit distance function is very much used in string comparison. It is the number of characters that you need to change, either by substitution or by deletion or by insertion, to change one string into another. So I think in DAA course we had the example intention and execution. So how many characters you needed to transform intention into execution, I don't remember exactly, but this last part seems to be the same. And there is one E here that is the same, so at least this N has to change into a C, and this U has to be inserted here, and E and X, yeah, these need to be changed also. So I think the edit distance here is 4, because 4 characters have to be changed, or this U has to be inserted. This T is also missing here, so another insertion. I think it's 5, but if you have the implementation from the other course, then you can check it out. Yeah, so this is how edit distance works on strings. How it works on the trajectories, it's actually very similar. I think I preferred my other route before, because yeah, the one where both of them are in the same order. So I refresh the page, now both of them are going down again. So to make it work on these kind of real sequences, you use this epsilon parameter, and you say that if 2 points, A and B, are closer than epsilon, then they are the same. So it is the same as looking at the strings example and saying that 2 letters are the same or not. So you can't just use equals sign like you check in the strings example, like is E equal to A? Because the point locations in the GPS trajectories have these small differences, these very small differences, and this epsilon value is like a tolerance value, and it will just say that if 2 points are close enough to each other, then they are considered to be the same. Otherwise, they are different points. And here, these red lines, they are happening because the black trajectory here has more points. So this means that if you want to transform the black one into the blue one, you need to have 3 remove operations. And if you count how many remove operations are needed, 3 out of the total of points that you have in the trajectory, you will get this 82% similarity, because all the other points are okay. So all the other points consists this 82%. So this is how the edit distance is calculated on trajectories. So this example showed the removal because one trajectory had too many points. But okay, in this example, the black trajectory has very few points, has just 5 points, and you can see how many points of this blue one now have to be removed. So all the others are removed because of the edit distance function, and now the similarity is even lower. In this example 4, here the distance threshold, this 90 meters, is broken. So this point, even if the trajectories would have the same distance here, if the blue one would have also 17 points, then this point is still not going to be matched because the distance to here is going to be greater than this epsilon value. So I'm not sure if you understood just from this explanation, but it is really the same as the edit distance on strings, just with this epsilon constraint there. And in practice, when you have real data, it's going to look like this. So all the points that don't have this kind of red line from one trajectory to the next, it means that they are considered similar. But any place where you have this kind of line, it means that that point has to be transformed by removing it, by adding it, or by substituting to another in the edit distance. So in the real examples, it may look quite different. But these functions have a little bit of a problem because usually people don't care very much about this sampling frequency. So if you are going to have two trajectories that are exactly the same streets, but one has twice as many points, then the similarity function is going to say 50%, even though if you look on the map, they look visually the same. Usually these apps don't display every point like I'm doing here, but they just keep a straight line in the representation. So it doesn't matter if you have points distributed like this or points distributed like this. It will still look the same. So from the visual perspective, people will ask, why aren't our trajectories the same? We even went together. We started at the same time from your house. We went to my house. My setting was 4 seconds recording interval, and your setting was 2 seconds recording interval. But probably they will never figure out, because statistic is the same, speed is the same, length and all the streets are the same. But this hidden feature is going to affect some numbers in the hidden processing. So, yeah. Anyway, this was a bit of a sidetrack, but much of the way Strava is working is based on this trajectory similarity concept. So I think it was worth to talk a little bit about it. Do you have more questions about this?
So how does Strava take into consideration this point frequency problem?
I don't know.
Yeah.
But it does.
Yes.
So I have to say that the results don't matter because I tested with different frequencies, and they still are considered part of the same segment and evaluated. One way of doing it could be interpolation. So if you have your trajectory that looks like this, and another trajectory that looks like that, and another trajectory that is very close to that one but has a higher sampling frequency, then what can happen is that if you need a higher sampling frequency, just add an artificial point in between two existing points. So add another point here, and now you can have this kind of matching happening between all of them. So it could be done. I don't know if they do it that way. Problems are in the thirds. So, okay, imagine that this here is the road network. It is a simple intersection. And now you're recording a point here, and now you're recording a point here, and now you're going here, you're turning in the intersection, but your next point is going to be here and here. In the interpolation stage, you will add a point here. It's okay, it's still on the road, but you will also add a point here, even though your true location was there. So there are a few situations in which this might not work as expected. You could map the point to its nearest road or something, but I just don't know. These are all speculations, and they could fix the problem, but without testing a lot, I couldn't figure out how it's done. Any other questions?
What can we get with the premium license?
With a
Premium application.
Can you
If you go the premium with the Strava, what can you get?
preview?
Premium version.
Oh, premium. Oh, yes.
Oh, sorry, how do you pronounce it?
Yeah, it's premium.
Premium?
Premium, but I understood preview. So
Yeah.
I didn't know what.
And I talked about premium.
Yes. Okay. Let's look at the premium in a second. First, I want to see. I went to this to explore the segments because I talked about them, but I didn't show how they look like. So I don't know if there are these overlapping problems that I talked before anymore, but yeah, I'm trying to zoom in and it doesn't work. So for example here, there are a couple of segments actually. There is this D segment, A segment, C segment, B segment. All of them are overlapping each other. And if you're going to track there, it will appear that you have seen 4 different segments. So it's going to be a bit confusing. They are all the same or partly the same. Let's go premium. I don't know what it means, and I'm not going to buy anything, but okay. Personalized coaching. So maybe you want to really be serious. Live feedback. I don't really know what they mean, but I guess there are some people that look when you are training and check your statistics and tell you what you have done good and what you have done bad. So it's not so much of the app features that would be missing, but some personalized service that they give. Okay, some features like filtering the leaderboard by age or weight. So, in my view, all it means is that you will be appearing more in the top on more lists. So the more lists you make, like if you list for every segment, is much better than listing for the full route, because you get many leaderboards. So on some of them you will be higher than on the others, and it kind of motivates you to try to be the best or better on at least some of them. And here, if you can filter by age or by weight, well, you can say I'm the old fat guy that is the best in Joensuu. So this kind of it's also for the motivation aspect. So some people think it's not fair. I am old. I'm like 60, and I'm in the same list with this 20-year-old professional sportsman. I want to know my real condition, so I will buy this feature. So yeah, I think some people probably get it for that, but I'm not convinced. Power meter analysis. So power meter is a tool that you put here on your bicycle, and it's going to record how strong you are pushing on the pedals. So this is a quite important tool for professionals. I don't have that, but it's yeah. I think it's important. So if you go premium, I guess you will have possibility to upload such data from these sensors into the system and get even better analysis of your statistics. So yeah, they give much more personalized result and a bit more features. Okay.
Yeah, what about the calculation about the segments? Do they sum these segments if you have some kind of route A to A, and there is a few segments? Is it come to A segments from the summation of the or
I'm not sure if I understand. So
I think have a route A to A, yeah, and then you divide it to the segments, and yeah, we can keep the A to A one segment, and the which is consisting of the segments. Is this totally the time to the total time to the A segment is addition, the summation of the segments?
Yeah.
Okay. Is it?
I think so, but okay. So yeah, if you have the segment A, B, and C here, and you add them, then it is going to get your original route. But the way Strava works is that these segments are not necessarily going to cover all the route, because somebody would have to create segments everywhere. In practice, the situation is that it will probably look like this. So you might have a segment A prime here, B prime here, and C prime here, but they don't cover the route completely.
Yeah. What about if you want to cover it? You start at A to B, and B to C, and to the C to A.
I think you can do that if they don't limit this creation from the web interface. So I think you can create the segment anywhere, but it might tell you that there are too many segments here, or it might say that this is too long segment or this is too short segment. So yeah.
I just thought that next time if you want to get a high score of the competition, you start with the riding with the car and make the that kind of system.
Yeah. Maybe if you go premium, they have option filter out people that are driving with the car. So yeah. Okay, but also one small thing I want to mention, and I don't understand why it's a problem. So I just mean that even though these apps are very popular, some problems are there. And I have here one trajectory. It's a very long one. It's 20 hours cycling. So it's a very long trajectory. It's actually 456 kilometers. And there is no speed graph. it might be that it's just too long for the system to handle. All the other ones have here this speed information, but this one, for some reason, the speed graph is unable to work, and it could be that there are just so many points there that the app is crashing for some reason. Also, probably not a very important feature to have, because usually the tracks are much shorter, but I tried to stress it to see if it works, and it has some of the problems, even though speed information is on the segments, so it doesn't just lose the speed, it's there. But this chart component here, it's unable to display the information, and I don't know why. Okay, and I would like to add a small thing that this is very similar to something that we have in Mopsy. So if you remember from yesterday, in Mopsy we have that drawing feature that I like. And I demonstrated that you can, for example, search any trajectory that looks like something that you are drawing, and you can find something like that. It's not a problem. But we also have a possibility, this is a more hidden feature, to find a trajectory that contains a specific part. So this is very much like the segments feature in Strava. When I'm going to release here, it's going to find any trajectory, any route that passes through that line. Not that looks like that line, but just passes through that line. So now if you have trajectories that go up like that or down here, they all pass through this. So it would be possible for us also to get statistics for each of these trajectories only here in this segment. It's not too difficult to calculate everybody's speed there. But the benefit with this system is that you don't need a segment database. So you wouldn't have these overlapping segments there. And you also don't have this kind of, like the other people don't know where you are trying to go very quickly. It's kind of a secret where you are comparing. So if there is a very steep hill somewhere, then you might make your idea for today, I'm going to go here as fast as I can. It's very likely somebody else is not going to try their best, because they don't know it's a segment. So it's even more likely for you to be higher on the top of the list. So it's a little bit similar to the Strava, but it's missing here. So it should have here for the segment that I drew exactly what was the speed for all of these routes there. So if I would add here the speed for that particular segment, it would be the same thing, just that you don't find by the database, you find it by drawing something. So yeah. Okay. I think that we can have a 10 minutes break. Okay, I think we can go on. So very small summary about Strava. Many small features, many top lists, these segments, simple interface, app available on the mobile devices, on iOS and Android, both of them. Facebook, Google login, they already have basically people, anybody with these accounts, with Facebook or Google account, can immediately play with the Strava app. So all of these small things, and there are a lot of small things. I want to attract your attention here. This one. What does it say here? Can you read? It says, yes. Small thing, very small thing, but it's very important. So I'm not called user or cyclist. I'm called an athlete. So I may not be an athlete, but if the app tells me that I'm an athlete, I'm going to pick this one versus Runtastic or Sports Tracker or Endomondo or the other ones, because it thinks I am very cool. So very small changes, but these are really what make the app better. That they are focusing, they are paying attention to all these minute differences, and overall they sum up to a better app, even though it's such a small feature that anybody could implement. Right, Waze.
Sorry, what do you think? How do you? Is it easy to get that kind of lodging system, like which use the Google or Facebook?
Yes, Google and Facebook offer this plugin for login, for authentication using their service. It's very easy to do.
Okay.
We had it also in Mopsy. The only problem is we lost the person who knows how to do it, and in time it changed. So this is something that you need to expect, that Google and Facebook will have some improvements, and then they will tell you in the next month you should upgrade to this new version, and if nobody is going to do it, it's not going to work anymore. So they are very powerful things to have, but you still have to be aware and maintain it, otherwise it will not work, and now we just don't have enough power and time to make it work again. So it's just a matter of a few lines of code, but yeah. So let's begin to talk about the Waze, and I think we begin again with the website. So Waze, they have also a nice video here. I think we can try the video out, and I'm not sure if Kuopio will have sound, but or us. Yeah. So volume help.
Welcome. You just became a Wazer. That means you're never alone on the road anymore. That's because you're now connected to the largest community of drivers on the planet. We share real-time traffic information and live recordings to help everyone bypass traffic, save time and gas money on their commute. So, just drive with the Waze app open, and you're already contributing a ton of traffic info that helps your fellow drivers. You can also actively record events you see while driving. All hands-free, of course. Waze's big brain rounds up all the real-time info shared by the community. It gives you the fastest route to your destination, every time. Even rerouting you midway if there's a better route. Waze learns the routes you prefer at frequent destinations. In fact, there's many too. Connect to Facebook to meet up, arrange pickups, and see the live status of your friends and colleagues arriving to an event or shared destination. Even Waze's maps update in real time. The community keeps them ever improving. Hey, you can get involved in map editing too. The bigger your community, the better Waze gets. So, spread the word, because when drivers work together, the road ahead gets a little brighter.
Okay, did Kuopio have any sound here?
Yeah, we managed.
Fantastic. Okay, so it's a navigation app, or an app that gives you directions how to go to different places. But really it has this community aspect to it. So what makes Waze different from all the others is something called crowdsourcing. You are essentially having a database that is constantly updated by everybody who is participating in traffic. And they have a nice feature here, live map. It's here on the top of the web page, and if we go to the live map, we can see Joensuu, for example, and it looks kind of boring. Let's zoom out a bit, check maybe Kuopio. Is it here or no, it's not there. I'm lost on the map. Yes, it's here. So Kuopio, well, there is some user here maybe on the map where the mouse is there. Not much activity really. But okay, some problem in Kuopio, some road is blocked here in this place, so you should know that don't go there today. It doesn't look so impressive because I think because in Finland it's road conditions are pretty good and more expected. But if you go to Helsinki, you should see a bit more activity there in the app. So more roads that are having problems. These are not necessarily problems, they depict the flow of traffic, so it just means that it's going to take a long time for your car to move there because there are many other cars. But really, I can say as a story that in USA this was extremely useful because if you go to a bigger place that is also prone to have many people and accidents and whatever, you are going to benefit more and more from this one. And that's why I mentioned some time ago that knowing your target audience. So I wouldn't, if I would own this app, I wouldn't advertise it too much in Finland because only a few people are going to really benefit from it. The road situation just doesn't change as much as in other places. But let's see what happens in New York. So, okay, this Central Park, so I think nothing is there. I mean, no driving there, but here some major roads are being closed. And here there is traffic jam, standstill, traffic jam, police trap, visible police trap, heavy traffic jam. So all of these things are actively reported by people. When they are driving and they see something, they press a button, it says, I see something here, and then they will have a selection of many buttons. What do you see here? And those things will remain active as long as somebody else doesn't press the button that says there is nothing here. So people are constantly asked, was there here a problem, a speed trap or whatever. So they simply have a database, and at the location that you have already from GPS, they populate the database with these different observations, different types of data. It's a very simple system, if you think about it. Just add location, put some new thing. But it has a huge difference on the way that the navigation works. And I think we can talk about that in the slides. So, how does navigation work in these road networks? I'm not going to tell you too much about it. You should remember this from the AA course. I think Pasi has taught this. I'm not exactly sure if he focused on it this year, but it's a basic algorithm. I think that it is studied also in high school. So this Dijkstra's algorithm gives you a shortest path between 2 points. 2 points on the map or any kind of graph. As long as you give it a start location and a destination, it can give you a shortest, lowest possible cost path in a graph. And there are many implementations in a lot of programming languages for this algorithm. So this is, I copied it from Wikipedia, and you can almost implement it in Python just by looking at the pseudocode. I think this is actually not pseudocode. I think it's some programming language. Yeah, or maybe not. But anyway, yeah, I think it's pseudocode. So this is the algorithm that is used throughout, with one addition. So it's something called contraction hierarchies. So it's written like this. Now, this Dijkstra's algorithm, as it is, I believe it is something like that. It might be in terms of the number of vertices and edges in a graph. So if the graph has number of nodes or vertices and edges, I think the implementation might be in terms of the edges, and maybe it has another logarithm component there. I don't remember exactly, and I don't plan to discuss too much about it. I just mean that the basic Dijkstra is quite slow, because how many edges are you going to have in the world? Many. You will have all the streets in the world, all the possible connections. They add up to quite a lot, and if you're going to calculate the distances from Joensuu to, let's say, Dubai, like what we did in some previous lecture, you will end up to traveling maybe up to 1 million of these road segments. It is possible. So very small road segments all the way there might add up to such a high number. But if you square that 1 million, it's going to be really a lot of processing, and it's not going to happen. You would get the result with Dijkstra's algorithm in months. So because of that, something called contraction hierarchies pre-processes the graph, and it pre-processes it in a way so that it figures out some pre-computed shortcuts. So for example, it's going to find out that you cannot go from Joensuu to Kuopio in many different ways. It knows that you must take one or two main roads, and then based on those pre-compute the two bigger links. So hard to explain visually, but if Joensuu is here and Kuopio is here, and now I'm going to draw all the roads in Joensuu. So one small road here, small road, small road, small road, and then at some point you end up on the highway, and then some Tuusniemi maybe here, and Riistavesi, Outokumpu in between. And then again you end up in the big city where you have to go around different things and take different small routes. This would be just pre-computed as a one link that is 135 kilometers using this method. So pre-computing it to get a simplified graph, and then after you get this one link, this simple link in the simplified graph, then you go in the detailed graph and ask, what does this link contain? And then you will find out these exact paths. So it's not a very simple way to speed up Dijkstra, but it's the way that is happening in this OSRM system that I'm always talking about. So one thing in this open source routing machine that I didn't talk yet about is the source code. So it's open source, it has a source code, and I can also confirm that it has many issues. So here it has 486 issues, and many different problems might exist in it, but it's also an active community, so they try to solve all these different problems. But the way the code works, and I'm not sure if I can find it here, is using Dijkstra. So this MLD here, I think stands for multiple something Dijkstra, multi-level Dijkstra, and the other component is this contraction hierarchies. So if you are interested to learn about how these algorithms work, this OSRM includes implementation of them in C++, both of them, and they work with OpenStreetMap data or any graph that you give it to. So good source if you want to learn about that, but that's not what we are going to talk now. We are going to talk in practice how do we work with the map. So if you open a Google map, then it looks more or less like this, but it has a lot of information that is not necessary for the road network. For example, city market is here, or this place is green because it's some forest area. The road network really looks like this. It's just a graph. The location of these nodes is important, so each vertex has X and a Y component, and you can calculate distances on it basically using Haversine distance or some simple distance function between any 2 points, just knowing that you are in this kind of space. So knowing the scale, you can calculate that, okay, it looks like this block here seems to be about 100 meters length. This one here seems to be 150 meters length. So you could calculate the distances on the graph just by using some distance function like Euclidean or whatever. But let's see how it happens in practice. So in this situation, assuming that we want to go from this workplace, Science Park is here, and assuming that I live somewhere in Penttila, how would I go from here to Penttila on the shortest path? This would be my question, and I would ask Dijkstra's algorithm, okay? And Dijkstra's algorithm is going to try different possibilities, many different possibilities here. It's going to really span and try to get to the destination in this quadratic space approach. But in the end, it's going to tell me probably, very likely, this. So that's how you go there. And it's going to say this is 2.5 kilometers. Okay? Now, how does Waze or some other, or Google Directions work? Because you might say, okay, I'm in a car. So you're in a car, not a very good drawing of the car. But if I'm in a car, then a car can't go on this bridge. This is actually a bridge. It's a cycling bridge. This is also a cycling path here. These are cycling paths. I think these are cycling paths also. So what happens is each of these segments has a property. Can it be traveled by car? Can it be traveled by a bicycle? Okay, something like that. Or do you have to go there and just walk on the path? They are all different properties of this one segment that we see here. In these situations, the car is not there. So because the car is not there, Dijkstra's algorithm is going to work with the subgraph. So if we say that we are in a car, it's going to, these don't exist. So how is the next possible way that I'm going to go there? Well, probably something like this. So this blue one only works if you have walking or cycling as your input, because the graph is different. The graph contains also these places that I called off, but it's the same algorithm. So nothing different there really. But yeah, but the graph is what changes. So the algorithm is still the same. Now, there is one more thing that is very interesting, because now when we calculated this green route, this is longer. So this is maybe 3 kilometers. We can consider that. And I would like to ask, thinking also about the Manhattan distance, why would Google say this and not say this, for example, because it's the same distance. Actually, anything here in this city area would equal to the same distance. So why would maybe some Google service or Waze or whatever choose this route over the others? Does anybody have a guess?
The left turns are much slower.
Left turns are slower. Yeah. Okay. So turns in the first case. So something like this is kind of unreasonable to just go right and left all the times. But what you said is exactly what answer I hoped for. So turns factor in the time of your trip. It's going to be much quicker to go straight for a long time than to turn very much. So now I ask you the question of objective function. So is distance, is the length really what makes a good app here, or do we need some other function that we want to minimize? And if you would add for a turn in the intersection a value, a weight, then that turn then your algorithm will prefer no turns. And really what is happening in these other applications is that length is not the thing that is being used for the minimization process. Instead, they use time. So this will be a bit clearer very soon. So let's say that you have the 100 meters. How long does it take for a car to go 100 meters? Probably 4 or 5 seconds or something like that. You could get some rule and just make an equivalence here for, let's say, 5 seconds. And if you just replace all these distances, like instead of 100 meters, there is 5 seconds here, and this one, instead of 150, it's maybe 6 or 7 seconds there, the algorithm is still going to work the same. It's going to try to minimize time, but in this case, time is fixed, is proportional to the distance everywhere, so algorithm works the same. But if you include that at the intersection point, the time will increase by 1 second if you are going to do the turn or not, then your algorithm will prefer less turns overall. So this is one thing that reasons how such a navigation system works. But now I ask, what happens if we get this kind of situation? So is time really a function of the distance in cities? Here in this place, it's very likely that you're going to get a traffic light. Traffic light may make your path even slower than necessary. What happens is that in the database, each of these segments here have different properties. Let's write them up here. So first of all, they have the properties of what movement type is supported on the segment. So this is something that is there. So can you go walking, driving, or cycling? And they also have an expected time for completing it with all the movement types. Because it's possible that it's going to be a very speedy road, that you could go very fast with your bicycle, or it could be a dirt road or some bad road that you go very slow with your bicycle. And it might be a street with no speed limitation, or 100-kilometer speed limitation, or 50-kilometer speed limitation. So depending on metadata that you have for every segment in here, your time estimation is going to change. And here in the center area, even though you don't have maybe such a low speed limitation, maybe it's 40 or 30, but you have the traffic lights. So there, it's an artificially added time there, because you will have a probability to get quite a lot of extra time on your trip there. So this is already, we are not yet at Waze, but you start to understand a little bit that we are not minimizing distance here. We are using Dijkstra's algorithm to minimize some objective function, which is calculated based on this metadata, like what are the transportation methods, what are the surroundings, is it a hilly place, do you plan to cycle there uphill? It's still going to add time proportional to that. So the time is not just a measure of distance, but it's a measure of as much metadata that you can get. And a lot of this information is available in OpenStreetMap data, for example. But now, I want to ask even more things. I want to ask about alternative routes. So let's simplify this a little bit and say that we are using Google, and Google gives you this path, but it also gives you an alternative route that says go here, go this path. So this blue one is 3 kilometers and this green one is 2.5. So if you have used the Google directions, you have probably noticed that sometimes you have options, 2 or 3 different alternative routes. How these are calculated is really still using Dijkstra's algorithm or some simple routing algorithm. Of course, what is the shortest path between these two options? It's going to be this, right? 2.5, that's the shortest path. This is not the shortest path, this is something else that we have here. So how do we get the alternative path? The way it works is that after you get the shortest path, Google or some system that does these kind of these navigations will artificially add some weights to the path that you have found as the shortest path. So when you increment these weights, it can be distance, it can be time, you just artificially add some values for the weights. Eventually it's not going to be the shortest path anymore. So some other one may have the opportunity to become the next shortest path. But you see that it's still a modular application, so it uses Dijkstra. So from A to B, it uses Dijkstra. After that, it increases the weight. And then it uses Dijkstra again, and then produces another alternative. So, okay, here is record alternative. So basically, it may give you multiple directions, but it still uses the shortest path component once more. And finally, going to Waze. So in addition to these kind of properties that you have for individual segments, like walking, cycling, driving, speed limit maybe 30 kilometers per hour, expected time maybe 10 minutes, because it contains some, I don't know, some extreme series of traffic lights or whatever. So these could come from metadata in a static database. But now what happens is that in addition to this static information, they have also information that is constantly updating. So assume that you have seen here some accident, some car accident. And now on the side of the road there is a car that you have to overtake. It's not going to, you can't go as fast anymore there. So if somebody reports such an event in that location, then automatically you will have on this segment added a hazard. And this hazard, depending on what it is, it has a probability of slowing you down, or an amount, a value of slowing you down. So again, it will affect your time component. It will increase it. But this data is existing now at the moment, and it will disappear as soon as some other user is going to say that it is going away. But what is happening is that you always add more metadata into your road network depending on the user's observations. So this is what Waze is doing, and it seems to have a lot of impact on users in places where these kind of incidents are very common. And of course road blockages and so on. So in a nutshell, that's how it works. Of course, it's not the whole. Yeah.
How do the system knows when the hazard is going off?
Somebody is driving there. Okay.
Oh.
Somebody is driving there. They will have their phone open, and on the route, it will say that here there is a hazard. So then the person is driving, is going to go to that hazard, and he will not see a hazard there. At that point, when you are at the hazard, the application asks you, was there a hazard there?
While he's going to the hazard, if he had chosen the other better road.
It's not always that you have chosen another better road. So not everybody is going to choose the different road, or it's possible that the hazard has no effect on your time very much. So it is possible that even with the hazard, you will still be routed in that direction.
So it's the difference to that kind of users who not use this application too. No.
Well,
yes.
they cannot add the change if they are not using that.
That's true.
Yes.
Yeah.
But yeah, so not everybody is going to go through them, and it will just wait for somebody to say nothing is here anymore, or at some point, after a time, after maybe 1 hour, they will remove from database automatically. That means that next person that drives there doesn't know about the hazard. Maybe the hazard is there, maybe it's not, but you just lost one customer who didn't get the information, and after he goes there, you will get the information back. So all of these temporary problems, you can assume that they get fixed.
Yeah.
And then new people will report them again and again and again. It will not be very nice for those few people that are having to report all the time, but then you don't have the problem of forever having the issue in the system.
Yeah. What is the business idea of this Waze application?
I don't know, but I can talk a bit more about crowdsourcing. So maybe this relates to what you asked now. So crowdsourcing is not only for these hazards. If you read what they do in Waze and you try the app, you will see that you also get updated gas information from the gas stations. So for example, you have a user that goes to take gas from somewhere, he will write there what is the value of that gas station in that particular place. And if you use the app and you say, I need gas, their algorithm is going to take you to the gas station that has the cheapest price on your path or not too far from the path. So now it relates to some real service where you are going to go and give money. So you could argue that one business plan could be to have a collaboration with gas stations or other of these providers and say, if you want your gas station in my database, give me some kind of money for that. So then it's included in their system of recommending the gas stations along the path.
Was there the gas station in your Waze application? Why didn't we see it then?
I think that this map that I was showing you is only for the road, conditions. But if you go to the main page, they have here special feature for that one. Sorry, special feature for this gas price updating. So it's probably not going to appear on the map unless you say that you are in need of a refill. So the app has this button there that are you looking for services, are you looking maybe for gas stations, and then you can search for things nearby. So this live map on this web page is only showing what problems are on the road, not these additional features.
Do you mean that the gas station was in the premium?
No, I don't think so. The premium, I don't know what the premium has here.
Yeah. Can we get the map of the gas station? No. Yes.
I don't know. I haven't found using the web system or the mobile system. But in the mobile, if you press the gas station button, it's going to find you near to you what are the possible places to refill.
In Finland too?
Yes, in Finland too. It works.
Okay.
But it probably doesn't have accurate pricing because, again, if you saw the map in Finland, not many users and not many people here will also mean that these prices are not updating so frequently. So, yeah. Okay, but going back to this Waze, so really, this crowdsourcing is used very much in this application, and it's the main reason why it's so popular, in my opinion. It gives you updated information even while you are driving. So if we go back to this example here, even while you are driving, so let's say that you are asking for directions and you are getting these directions to go to your home. And while you are driving, while you are here, some accident happens here and somebody reports it. What the application does, I think, in the background is as you are continuing to drive, so you continue to drive, it constantly recalculates what is going to be the shortest path to your destination. And at some point, if it figures out that this is going to be shortest in terms of time, so not in terms of speed here, then it's going to say, hey, we found a better route for you than what we have calculated before. So it's going to give you the option to reroute as you are going. But I really want you to notice that all the features that we talked here are shortest path calculation using different objective functions. So instead of shortest in terms of distance, it's in terms of time. It's using a very complicated database. Not complicated, it's a simple database, but with a lot of metadata. A lot of metadata and also updated metadata that has a lifespan. It will disappear when the hazard has gone away. Also here I forgot to mention delays. So when you have your application open, even if it's not a hazard, if for some reason you needed 10 minutes to go this segment, which is 100 meters, it means that something there is slowing you down. It's very likely to be a traffic jam or some slow traffic on that section. So even without pressing any button, they can infer how long it's going to take for somebody else to go on the same road based on the traffic. So this is what can be done. But it's all of it is some shortest path or minimum cost, depending on your cost function, on a graph that has very good metadata, and because of the crowdsourcing features in Waze, it's very helpful. It detects these problems as you are driving or before you're driving, but it knows much more than a typical map has information. So that's, I think, the reason why more people are using that. And I have to say that while I was at this conference in this LBS conference, I found a lot of bad things that are coming from this app that you might not think about. So I will mention one at least. Can anybody think what is bad about Waze? Because so far it is solving so many problems in real time and so on. Can anybody think of a side effect, a bad thing that is caused by Waze?
Have you ever met who use this Waze?
Yeah, if you go to Southern Europe, it's full of it. So it's very popular. If we go now to this live map in...
We don't have a problem.
Yes, you don't have problems. But usually big cities, I think it's especially popular in USA, but big cities that also have problems. So Helsinki is quite big, Tampere is quite big, but the number of users is quite small. However, if you go to Southern Europe, Western Europe, you are going to have very similar situation as in USA. So a lot of information that is constantly updating.
One problem is that the phone battery goes away when the location is always on.
Phone battery, yes, but in the car you usually can charge your phone from this car light.
That wasn't a problem.
No, I think people that are driving a lot know about this, so it's not a problem.
What was they just made? That this application disrupt the drive.
They try to have the application so that minimum touch is necessary. So all information comes to you, and when you give information, it's just a tapping on the screen. Sorry, okay. Bilal has a question. So,
what if people report false information?
False information. Yeah, maybe bots or just people that want to report false information. It can be a problem, but I think they just disappear over a time, and they have a way of strengthening the claim. So if somebody says here is something, then something will come again. But assume everything is working perfectly. What would be the downside of Waze?
There could be some kind of security problem.
No. Well, yeah, of course, but I mean a problem that is caused by the system working perfectly.
Can people take advantage of the system?
Not advantage, but I can say in a very short way, in a very short sentence, peaceful neighborhoods are very much traveled nowadays. So you had peaceful neighborhoods. You have neighborhoods where you have schools. You have neighborhoods where people with small families, with small kids, are moving on purpose because they know it's a peaceful neighborhood. And because Waze has this system of figuring out what is what are crowded streets, it's naturally going to route you to the streets that are peaceful. So what is happening in the big cities is that the peaceful neighborhoods are giving a lot of complaints to this app that, hey, stop taking people to my streets because now it's full of cars and my kids can't go outside anymore.
Why they don't put the hazard flag on?
Well, I guess maybe some parents are doing that. They keep ways open all the time. And hazard, police, don't go here. Yeah, so I just wanted to mention that even though these apps are really top, like they are used very much. If you look at the number of users, I don't remember anymore, but I think this Waze is 1 order of magnitude less users than Facebook. So if Facebook has like 100 million users, this Waze has 10 million users.
Oh.
So it's a hugely popular application, and I would say mostly because of this police visibility. So many people like to know when police is coming there, even if they plan to do overspeed or whatever or not. They just like to know if police is somewhere. Of course, the hazards and the other things are also useful, but they even have some kind of, in my opinion, some kind of joke on the main page.
Welcome. You just became
Or
a Wazer.
I don't know if it's on the main page or not, but I consider this a joke. It's like, why is this police there? So, yeah. So it has a very, very large user base, but still it has problems and it has some users that are not happy about it. Definitely, if you think about target audience, it's not going to be very happy for the people that want to have a quiet neighborhood. So target audience, whenever you make any kind of app, is not going to be everybody. So that's one thing that, yeah. So and also, even if it's a very good service, it will produce problems even without it working. Even if it's working perfectly. So it's just designed to cause these other problems. Of course, everybody using the app is happy because they get faster to their destination, but it's not all about driving. So I think we are out of time. So I think we meet at the exercises on Friday and then 1 week break. So see you.
Okay, see you. Thank you.
Thank you.